Okay, I've graphed this exponential decay function on Desmos. That's this red graph right here. And I've set a sub 0 equal to 1,000, which comes into play for parts B and C. But for part A, it really doesn't matter what a sub 0 is, because when you're asked for the half-life, you want to know when half of what you started with is left over. So let's say that really this was equal, let's say the original amount was, 500. And it's still e to the negative 0.56t. And we want to know how long, what is t, before there's half of what we started with left over, which would be 250. And by the way, I'm assuming t is in hours based on this comment right here, after 12 hours. So if I want to solve this equation for t, I'll divide both sides by 500, and I'll get 1/2 over here. And that will always be the case when you're asked for a half-life. I'll always get a half over there, or 0.5. E to the negative 0.56t. Now I take the natural log of both sides. That's how you solve an equation where the variable or the unknown is in the exponent. Take the log of both sides. Log, I'll write it as 0.5 instead of 1/2, equals, and applying one of the properties of logarithms, I can move the exponent down front, and I'll write the log of e here for emphasis, but the natural log of e is just 1. So I can finally solve for t by dividing both sides of this equation by negative 0.56, which is what I did right here. And that's the half-life in hours for this potassium-42. And I have a table over here where I put various x sub 1 values in the table and calculated the a of x sub 1 corresponding values. And you can see that when a is put into this table, which is this 1.2377, that I get a value of 500, which is half of what we started with for parts B and C. Now for part B, how much will be left after 12 hours? That's this entry in the table right here. I'm finding A of 12, or I'm putting 12 in for T. And remember, there's still a 1,000 here, because when t is 0, e to the 0 is 1, so a sub 0 is the initial value. And finally, if I start with 1,000, same equation, this one right here. Well, actually, there'll be 1,000 right here for a sub 0. I want to know when is the function value equal to 200. So I'd have an equation that looks like this. 200 equals 1,000 e to the negative 0.56t. I'm afraid I covered that up. So let's go down here. 200 equals 1,000 e to the negative 0.56t. Still divide both sides by 1,000. Over here, I didn't actually simplify 2,000 over 1,000, but I could see that simplifies to 1/5 equals the log of both sides, natural log of both sides, which will give me, well, I messed that up, which will give me negative 0.56t. I'm sorry, e to the negative 0.56t. I take the log of both sides, and this is the log of 0.2 equals the natural log of that thing, but I can pull this exponent down front, So I'll write this as negative 0.56t times the natural log of e, but the natural log of e is 1. So finally, to get the t value, I divide both sides by negative 0.56 here, as I did for part C. 2.87 looks to be about right. And if I put that value of c into this table, you can see that I do get an answer of 200. Okay, so hopefully that was clear. This down here is the link to the Desmos graph, and I'll also include that URL in the final answer.